1/8 plus 3/8. And give me the answer before you simplify it first. Jack? If you simplify it, what do you get? Alex? How many of you have 1/2? Great. Think about back to when we did do ratios. It's really the value of the ratios what simplification is. 3/5 plus 1/5. Charlie. 7/12 plus 4/12. Mad Dog. These are already simplified, so we can circle them. All right, let's do subtraction. What's 7/9 take away 3/9? Steven.
4/9.
And finally, 5/6 take away 4/6. Z.
4/6.
I mean, you got them all right. So what's the rule when you have the same denominators? What's the rule for this? Bridget? Right, the denominator stays the same, and then the numerators, depending on whether it's addition or subtraction, you add or subtract the numerators, okay? All right, let's go to the first example. What we do in Module 2, Lesson 1, is we're going to start off really, really simple. I know you can do 12 divided by 3 in your head. But what might be new to you is how to model it using what's now called a fraction bar, which is kind of like a tape diagram. Call it a fraction bar. We start off with things that you know, but we're going to build on that. So it's necessary for me, as your teacher, to start you with things that are going to be reasonably easy and comfortable for you. And then once you master that, we kind of build and build and build throughout the rest of the module, and it becomes a little bit more challenging. So let's start off with modeling 12 divided by 3. How many boxes do you say? And 12 of them, right? You got to kind of think when you think of what division is, you're really asking how many groups of 3 are in 12. That's what they're really asking you to do. That's what division is. So if we were to take this whole amount of 12 and put them in groups of 3, there's a group of 3. That's one group. There's my second group. That's my third. And finally, the last group makes 4 total groups. Everybody understand that? So in essence, there are 4 groups of 3 in 12. Or 12 divided by 3 is 4. Make sense? Try this on your own. 12 divided by 4 using a fraction bar, and I'll call you up. Charlie, come on up and model it. I'll try to get to everybody throughout the course of the year. Let me just scroll this up a little more so everybody could see. Too much. Go right there. All right. How many of you have this? All right, excellent. How many groups? Therefore, 12 divided by 4 is 3. Not that we're supposed to really put anything in this last sentence here, but really when you ask what division is, you're really asking yourself how many of a certain number are in a certain number. Whether in this case is how many of 3 are in 12 or how many 4 are in 12. We can do the same thing with fractions, and that's our next example. So go to the next page. And now you have your first fraction. 8/9 divided by 2/9. What you're really asking, or what they're asking you, is this called a think statement? How many 2/9 are in 8/9? So let me take you through the process. First, let me ask you this. What is each box? How many boxes are there? Count them. How many boxes do you have? You have 9. What is the value of each box as a fraction? Max?
1/9.
One out of 9 or 1/9. So we're going to first start this off by modeling 8/9. So how many boxes do you have to shade to show 8/9? Doug? Okay, let's shade 8. That's my tape diagram or fraction bar. It's kind of the same thing. Modeling 8/9. We want to put them in groups of, tell me, groups of 2 or 2/9. So here's a group. There's 1. There's 2. There's 3. And it works out perfectly. 4 groups of 2/9. Therefore, 8/9 divided by 2/9 is what?
4/9.
Common mistake. It's not 4/9.
No, 4, 1. Like 4.
Guys, ready? Ready?
4.
How many groups of 2/9 are in 8/9? How many?
4.
That's our answer. It's that simple. Don't try to make it a fraction if it doesn't require a fraction. The number of groups that you come up with is your answer to that division problem. Try the next one on your own. You could. You could. Same thing, same value. All right, try the next one. Model it. I'll come around and take a look. All right, my man Anthony, here we go. Do you remember what you wrote out?
Yeah.
Okay. All right, good. We're up and running.
Do another color.
And if you want to circle 2 on your own, that's fine too. Bracket or circle is fine. Or put a box around it also. That could work too. As long as you demonstrate it.
Can you shade it?
I would shade and then either bracket or circle. How many of you have 3 groups? Let me scroll down. All right, fill out the rest, Ant. Change that for a minute. You're putting them in groups of 3.
Oh.
I wouldn't take off points for 3/12, but you're putting them in groups of 3 because I want you guys to see that the number of groups is the answer to the division problem. Good? You ready to take a small leap?
Yeah, I like flying.
Do the next one. Yeah, Jack. All right, do the next one. It's a little bit of a leap, but you can do it. How many boxes am I going to make in my fraction bar?
9.
Okay. I'm going to shade how many?
7.
Everybody was good up to that point.
Yeah.
Groups of?
3. 2.
Groups of?
3.
3. How many groups of 3/9 are in 7/9? So watch what happens. there's my first group. I have 2 complete groups. I don't have a complete third group, do I? Okay, here's where some of you made your mistake. I'm going to bracket it anyway. In that group of 3, how many are shaded?
1/3.
2 and 1 out of 3, or 2 and 1/3. Some of you put 2 and 1/9, and you were close. But you got to think, how many in that last group are shaded? It's 1 out of 3. So it's 2 and 1/3. All right, go to the next page, and this is my question for you. Do you guys see the little shortcut that you can take? Do you see the pattern or the shortcut?
Yeah.
To help you, let's just refresh our answers. You've done these already. 8/9 divided by 2/9. When you did it, the first example was 4. This was 3, and the one we just did is 2 and 1/3. Do you see the shortcut? What do you notice? Take a look at the fractions. Look at the answer. All right, dog guy, what do you say?
It goes 4, 3, 2.
Nah, that's just a coincidence. Z.
You don't even have to divide the denominator, you just divide the top number.
Yes. Does everybody see that if the denominators are the same, all you're really doing is dividing the numerators. So what's 8 divided by 2?
4.
What's 9 divided by 3?
8.
And 7 divided by 3, even though you may or may not see it that way, if you go 3 into 7, it goes twice. A remainder of 1, 2 and 1/3. So that's the shortcut when the denominators are the same. I mean, obviously, eventually, we're going to get to dividing fractions and mixed numbers with unlike denominators, but we've got to be able to walk before we can run. All right, this is what we have for the rest of the period. I'm going to write some numbers on the board. If you are in the unsalted group,
I don't like being I want to be salted.
7, 8, and 10 pages, and advanced 7, 8, 10, 11, and 12. We're not going to do the problem set. We're going to skip it. Okay? No matter what, you have to skip page 9 because there's typos. So regular are doing pages 7, 8. This is pages, guys. 7, 8, and 10. Advanced are doing 7, 8, and 10, and then 11 and 12.